মিউট করো ইয়েটা।
अल्फारा जी प्रोग्राम लाइव है, यू कैन स्टार्ट।
Okay, we'll start. Good morning to everyone. Today we have assembled here to mark and celebrate 200th birth anniversary of Gregor Johann Mendel. You know that we know him as the father of modern genetics. We also know that he was a monk. In spite of that, those days people used to practice religion as well as science, mainly natural science altogether. And he was, in spite of that monastery, he was intellectual, he had good hands of experiments, and he was also a natural gardener because he comes from a farmer's family background. So for his later on, for some teaching assignment, he had to get some degree, and he went to Vienna, where he experienced and he was very much influenced about Doppler's experiment. That time he realized that in biology it was very descriptive. There was no proper documentation of underlying principle, or there was proper organization. So later on we see that in his experimental records and so on, he tried to fill up that gap, and we see like how that progressed to our later on our concept in the genetics. So today our speaker is Professor Partha Majumder, who needs no introduction to this audience. He is currently the National Science Chair and Distinguished Professor of NIBMG. And I hope that today we'll learn more about Mendel's work and his science from him. So with this little introduction, I invite Professor Majumder to be here, and we hope to hear a fantastic talk as well as a class and lesson from him today. Thank you.
Well, good morning, everyone. It's really a pleasure for me to give this talk. Thank you very much for inviting me on Mendel's bicentennial. Again, I'm very honored and pleased to be able to deliver this talk. Very recently, about 2 weeks ago, I was talking to a kid, well, not really a kid, he's studying in class 9, and I asked him whether he knew who Mendel was. His eyes lit up, and he essentially said, "Oh, I know him. He was a monk." So I said, "What else do you know of him?" He was able to narrate, in broad terms, quite well, Mendel's laws. So he knew about the fact that Mendel is a monk. So that's the reason that actually drove me to get this title of today's talk, a man of God. Monk is a man of God, I suppose, and a paragon of science. And it's the Second phrase that I'm going to impress upon you, that he was really a paragon of science more than a monk. I will start with a poem that was written by Thomas Hardy, and I'll let you read this poem. I'll stop for 30 seconds and let you read this poem. There's a particular reason why I'm showing you this poem, and of course, I will narrate why I'm showing you this poem. All right, so the reason why I'm showing you this poem is essentially to highlight one single line which captures what Mendel had done. And that's the line, "Flesh perishes, I live on." This is essentially what Mendel told us. How do we live on in spite of the fact that we are dead and gone? We live on through our children, and how we live on is essentially what Mendel had shown us. Also, I want to highlight another fact. Well, we are celebrating Mendel's 200th birthday. This is the 20th of July, 1822, when he was born. Today is 2022. And the two people who actually shaped modern biology are Gregor Mendel and Charles Darwin. There's no controversy about this. I do want to highlight a particular date, which is 1917. Which is the date, which is when Mendel was actually long dead and gone. Yet in 1917, Thomas Hardy wrote this poem, and multiple people have interpreted this particular poem in various ways. I'm not going to go through the interpretations, but they have. 1917 is important primarily because, well, for one reason, Mendel was dead and gone, and secondly, this was after the rediscovery of Mendel's work. For those of you who may not know what this rediscovery phenomenon was, I will narrate a little bit. Start with the disclaimer that I'm not going to describe Mendel's laws at all. So this is not I'm not going to describe Mendel's science. I'm going to only highlight the fact that Mendel was indeed a paragon of science, not as opposed to, but in contrast with his being a man of God. So so this is where he was born. This is in Heisendorf, essentially in the district of Moravia in Austria at that time, now in Czechoslovakia. So this is the house where he was born. And like this kid said, class 9 kid said that he was a monk. Indeed, he was a monk. But he also said that my circumstances decided my vocational choice, which essentially meant that he didn't really intend to become a monk, but some circumstances, and I'm going to narrate some of those circumstances, some circumstances led him to this particular vocational choice. He chose, priesthood as a vocation, and there are certain circumstances that I will, again, like I said, I will narrate to you. His father's name was Anton. His father owned a small farm. It was really an orchard where they grew fruits, etc. And one day when he was working on his farm, a big log fell on him and he became crippled for life. He wasn't tied to bed, but he was crippled. Yet he had to do various kinds of chores in the farm, primarily because Mendel was often sick and confined to bed. We don't really know why he was sick at that point of time when he was really a kid, but Anton had to work hard to make both ends of his family meet, and Mendel wasn't able to help his father so much. At a later point of time, we have some evidence as to why Mendel would continue to be ill, and I will tell you at a particular year when he was very ill, and the reason for that is quite well known now, but he was ever since he was a child, he was actually quite sick. His father had said, "He's a disappointment for me." And this Mendel obviously did not take well. He was not close to his father. He was close to his mother and his elder sister. And the reason why I suppose, Father Anton said this is primarily because he himself was crippled because of this falling log, and yet he couldn't get his son to help him. And therefore, the father was quite disappointed. Mendel completed his schooling in a gymnasium. Gymnasiums were schools, essentially, in Austria, in Troppau. He did well in school. He enrolled in Philosophical Institute. Because he was a high achiever in school, he was allowed enrollment in the Philosophical Institute. Essentially, that prepares people to get into the university for higher education. This is the time when he fell sick and he almost lost a whole year. And, he felt he was in his teens at that time, and he fell sick for a complete year. He was stuck to bed, tied to bed. And the reason is that he was actually suffering from depression. We don't exactly know the cause of his depression, but legend has it, or folklore has it, that he was depressed primarily because his father did not like him. And secondly, I suppose he had this guilt in himself that his father, in spite of this, crippling phenomenon that he had, Mendel wasn't able to help his father. So this was a guilty conscience that he had. Together, he was quite depressed for a long period of time, almost a whole year. He lost a whole year. Anyway, his physics teacher in the gymnasium, his name is Friedrich Franz, made a life-changing suggestion to him. And Franz himself was a priest. And what was that life-changing decision? He informed Johann Mendel, that the Augustinian order of the Catholic Church valued intellectual pursuits. At that time, much of science, much of intellectual pursuits was actually carried on under the roof of a church or various churches, and the Augustinian order was particularly intellectual. Franz suggested to Johann that priesthood could offer him a path to learning and teaching, and this is essentially what Mendel really wanted. So he grabbed that suggestion and joined the St. Thomas monastery in Brunn, which is now in Czechoslovakia, in 1943. He was born in 1843. He was born in 1822. So he joined the monastery in 1843. This is the Augustinian monastery, and that's essentially where the monks lived, and this is the church where all of the prayers and all of that went on. So that's what can be seen here. When he joined the monastery, when he joined the church, his name was changed from Johann to Gregor. So today we know him as Gregor Johann Mendel. Johann became his middle name, and his first name became Gregor. This particular monastery, the Augustinian order, this monastery was guided by a credo, which is from knowledge to wisdom over prayer. So you can imagine that this particular order of the Catholic Church was very, very different from the others, and the important word here is over prayer. So it's all of us think that church and the temples are essentially meant for prayers to God, etc., etc. But this is where this particular order of the Catholic Church differed, which is that they valued knowledge and wisdom over prayer, and this is essentially where Mendel had joined, and therefore, more than a monk, he was actually interested in knowledge and wisdom and learning, and that's what comes across. If you read his biography, he doesn't have too many biographies written. There's a biography written by Aurel, which is a very thin book, but it's very readable book. So this is the order, the Augustinians who had joined, and that's Mendel in the arrow. That's Mendel, and this is a bunch of priests that he actually worked with. One person comes across in his life as outstanding, and that's an abbot. Abbot Cyril Knapp. Abbot Knapp was actually a scientist. He was the president of the Agricultural Society in Brunn. He was also president or secretary of the Society of Breeders, Animal Breeders, etc. But Cyril Knapp was actually very, very outstanding and helped Mendel at different points of time in his life. Mendel, he actually encouraged Mendel to start breeding because he himself was a breeder. Cyril Knapp was a breeder. And Mendel started to breed mice, but the bishop, who is above the abbot, was furious. The bishop said it's inappropriate for a priest to see sex. The mice would obviously have sex and have children and so on and so forth. So Mendel then said, okay, the bishop is angry with me. I'm going to go away from mice and start breeding plants. And when he said that, Abbot Knapp, who had administrative powers in the church, built a greenhouse for Gregor Mendel to start breeding plants. tongue-in-cheek, Mendel later said, you see, the bishop didn't understand that plants also have sex. So this is, you can imagine that he also could make statements tongue-in-cheek, and this is something that Mendel has actually said and written. He didn't write it, but it's been documented. Like I said, that Cyril Knapp actually was, I forget whether he was the president of this or the secretary of the Society of Animal Breeders. In one annual talk that Cyril Knapp was giving, he said lots of things, but one of the questions that he posed in that particular lecture is we should try and investigate what is inherited and how it is inherited. That particular phrase caught on Mendel. And actually, if we want to give any credit to asking these kinds of questions, it's actually Cyril Knapp who inculcated this whole idea of you need to investigate what's inherited and how it's inherited. So this is where Mendel spent a lifetime. We know that he had gotten answers to this particular question, and so we, really the world remembers him for that. This is exactly where the greenhouse was built. It used to be called the glass house. This is where it was built, and this is essentially where Mendel did all his experiments, the breeding experiments, plant breeding experiments. So he was ordained a priest in 1847 after he studied for 5 years. He started to work in a parish hospital caring for the sick, but he could not see blood. He oftentimes felt sick seeing blood. And the world must be very, very grateful that he actually felt sick seeing blood. Otherwise, he could have been a nurse, he could have been a doctor, we don't know. At least he probably would not have been a geneticist, and we wouldn't learn the kind of things that we have learned from him. When he repeatedly fell sick because he was sent to this parish hospital, Abbot Knapp again came to Mendel's rescue. He sent Gregor to Vienna to study at the Royal Imperial University, and Gregor actually studied there from 1851 to 1853. There were some stellar people who actually taught him in Royal Imperial University. One was he took a course on plant hybridization, and this was taught by a very famous botanist called Franz Unger. He was also taught physics by Christian Doppler of the Doppler effect fame. And he took courses on combinatorial mathematics. And at that time in the Royal Imperial University in Vienna, you can imagine the kind of courses that were being given, very modern courses, modern even by today's standards, plant hybridization, Doppler effect, combinatorial mathematics, and all of those kinds of courses. And Mendel actually took some of those courses that prepared him for a lifetime. And I'll again explain some of that very much. From various documentations, we understand that Mendel was constantly in a tug of war between science and orthodox religion. He obviously learned to love science, and he already had started doing various kinds of experiments in modern biology, but he was also in the precincts of a church where religion was being practiced. So it was a constant tug of war in his own mind between science and orthodox religion. We must bear that in mind, and eventually it's the science that won him over, won him over, and we remember him more as a scientist than as a monk, even though the common man and even the students early on, they know him as a priest and a monk. So he also, it was also quite interesting that he wanted to do research and gain knowledge and also become a professional teacher. So he was interested in research and teaching. Again, like he, oftentimes felt sick by seeing blood. We are fortunate that he did not pass his examinations to become a professional teacher. You needed a certificate in order to become a professional teacher. Cyril Knapp actually gave him an appointment as one of those, not a semi-permanent kind of a teacher, but he had to pass this examination in order to be able to become a permanent teacher. He took the exam once, failed. Again, a few years later, he took the exam again and started to argue. So this exam came in two parts. One is the written exam, the other is the oral examination. He passed the written examination, and in the oral examination, he started to argue with one of the people who was actually interviewing him, and he failed. So we are lucky that Mendel actually didn't pass that examination. He probably would have become a college teacher somewhere in Austria, and we would never have gotten the science of genetics from Mendel. So Mendel was very sad that he failed this certification examination. He was interested in this primarily because he needed to support his family. So he was very sad, not because he failed, but primarily because he would not be able to support his family financially because he couldn't become a professional teacher. These are peas. These are actually pea pods or pea shoots. And this is in a park in Brunn. Where you see lots of people. It's in the park in Brunn, and very, very many people come and enjoy this particular sculpture. I don't know who made the sculpture, but anyway, it's there in the middle of the city in Brunn. There were two people. So when Mendel started started thinking about plant hybridization, wanting to do this, he also obviously started to read, like all of us do. We need to review the literature and see where science at that time stands. And so he started doing exactly the same thing. There were two people called Reuter and Gartner who actually did some early hybridization experiments using tobacco plants, and Mendel started to read them. Read what they had written. And what they had written was, again, they also asked this question about inheritance, about transmission of traits in the tobacco plant from one generation to another. But they felt that it was blending inheritance. And blending inheritance is like the character in the offspring is because of some kind of blending of the measurements in the two parents or even the ancestors. So this used to be called the blending inheritance, and that was the dominant thought at that point of time before Mendel propounded his laws. And again, like I said, that I will spend a little bit more time on this. And Darwin also believed in blending. So blending inheritance was indeed the dominant thought at that point of time. But Mendel doubted the theory. He could not believe that blending would be the way that characters are transmitted from one generation to another. And it is these doubts in his mind that made him do these kinds of experiments. That eventually these experiments in the garden of the St. Thomas Monastery. These experiments, again, I'm not going to describe these experiments to you. All of us are fairly familiar with these experiments. They were breathtaking in their brilliance in planning. So if you read this, small report that he wrote called Experiments in Plant Hybridization, it is organized very systematically from simple crosses to dihybrid crosses, to trihybrid crosses, etc. And as he went from these simple crosses to dihybrid crosses, there were interesting questions that he was asking, and that's all narrated. So he was asking more and more complex questions that needed more and more complicated experimentation and planning. So if you read it, it's really breathtaking in their brilliance. But once you start reading experiments in plant hybridization, you have to go move yourself back 200 years and put yourself there, because at that time, whatever the knowledge was, today, if you read it, it sounds very mundane, but you have to go back at that point of time and imagine that nobody knew what was going on. And this is how this man is asking these kinds of questions and planning these kinds of experiments. And it's just absolutely breathtaking. Also, the observations, you do an experiment, but you need to observe the outcome of the experiment. Observationally, it's just absolutely astounding. And the kind of analysis that he did and the interpretations, the kind of analysis that he did was very different from what used to be done at that time in biology. Biology was essentially observational. Darwin brought in a little bit of quantitative feeling into biology, into observational biology, but it was Mendel who should be credited with the complete systematic quantitative thought, counts, making ratios, calculating ratios from all of that, and coming to appropriate inferences. So first of all, it was like I said, breathtaking in its brilliance in planning. The observations were excellent, and you observe, but you need to keep records, and the record keeping was absolutely brilliant and meticulous. And then from those observations, which are quantitative in nature, he counted and then derived certain ratios, and from those ratios, he was able to eventually derive the Mendel's laws, which I'm not going to explain to you. But all that I'm trying to say is that this man was thinking of the questions in a logical frame of mind, sequentially getting more and more complicated in terms of the questions that he was asking, and planning his own experiments in such a way that those complicated questions can be answered appropriately. And therefore, Mendel completely stands out from all of his contemporaries at that time, including Charles Darwin. So he presented the results of his experiments in the society, in the annual meeting of the Society for the Study of Natural Sciences in Brunn in 1865. And the historian, science historian Lauren Isley, has written, stolidly the audience had listened. No one had ventured a question. Not a single heartbeat had quickened. Not a solitary soul had understood him. So this is what happened. It was pin drop silence throughout his lecture, pin drop silence. After his lecture, the audience dispersed, Mendel dispersed. So this is what happened in that 1865 annual meeting. The proceedings of the meeting were published, and this was his famous report, Experiments in Plant Hybridization. It was published as the proceedings of the meeting in a year later in 1866. Over the next 34 or 35 years, there were only 3 citations to this work. Not a solitary soul had understood him. So how would they cite? So there was only three citations to his work. And of course, Mendel was too far ahead of time. Indeed, he was too far ahead of time. He could have suffered, but he did not suffer as much because he was a very positive person. Towards the end of his career, this is what he wrote. I have experienced many a bitter hour in my life. Nevertheless, I admit gratefully that the beautiful good hours far outnumbered the others. My scientific work brought to me such satisfaction, and I'm convinced the entire world will recognize the results of these studies. Later, he said, my time will come. And of course, we know that his time had come, not right then. He didn't live to see his time come. His time came in 1900 at the turn of the century, and in 30 seconds I'll come to that. I just also want to point out that aside from these kinds of plant breeding experiments and the results that he was deducing, he was a scientist in the with a true bent of mind. He was a co-founder and active member of the Brunn Scientific Society. Like we have the various academies, etc. There was a Brunn Scientific Society at that point of time, and he was a co-founder of that society. He was a weatherman as well, and he established a weather station in the monastery, in the St. Thomas Monastery. He wrote about weather forecasting. He studied sunspots. Imagine we see these dark things in the sun. Those are sunspots, and he actually studied them. And when I say studied, he actually systematically studied and recorded what his observations were. He was also probably the father of epidemiology in some ways. He observed, he analyzed epidemiological data. Again, he was completely sold to quantitative reasoning and quantitative observations. So he himself kept lots of epidemiological observations and looked at correlations. The correlation, the way that we use correlation today, had actually not been proposed at that time. We didn't have that was proposed by Carl Pearson later, again in the context of Mendelian inheritance, but that was proposed much later, the Pearsonian correlation coefficient. But he was looking for associations between changes in the water table and how various kinds of diseases, the prevalence of various kinds of diseases was changing, etc. So he was in some ways also founding the science of epidemiology. He was a beekeeper, and he bred bees in spite of the bishop. He actually was the first to breed bees systematically in spite of the bishop. He provided the first ever description of a tornado that swept through Brunn in October 1817 and 70 and caused much damage. So he was a systematic person. He was a good observer. He was a good recorder. His mind was working quantitatively, and that's why we think that he was a fantastic scientist, because he asked the right kinds of questions, asked them logically, designed his experiments, kept the records, analyzed the data, and deduced inferences from all of that. So that's essentially the method of science. So he was following the method of science, and not just following, he was also promulgating some of the methods of science that as we know today in modern science. Times became unfavorable in Austria. Russia annexed Austria. The monarchy at that time in Austria fired hundreds of scholars and academics from teaching positions for political reasons. Bad times. Scientific disciplines such as philosophy were barred from the university's curriculum. Academic freedom in Austria was completely curbed. And here is Mendel, who is doing these experiments in a church, in the monastery. So you can well imagine what would happen to him. But it didn't, because he stood up. He did a petition titled In the Interest of Mankind, and he collected signatures. He did a signature campaign. Remember, we know him as a monk, but this is what he's doing. He's standing for academic freedom, not for religious freedom, but for academic freedom. And so he went around, collecting signatures, doing the signature campaigns, etc. We don't know what impact that had, but of course, things loosened a little bit in Austria at that time. But again, it was to come back to Russia and all of the regions that Russia had occupied a little later. He said, my time will come. 1900 is when his time had come. And how did his time come? They were, when we ask a question, we think that we are the only one who is asking this question. But there are multiple people around the world who are asking the same question. It's important to ask the right question at the right point of time, but it's more important to work hard, to work fast, and get an answer to that question. So at that point of time, there were other people who were working, and we didn't have the internet, we didn't even have postal systems at that time. So how would people know who was thinking and who was doing whatever kind of work? So anyway, three people, one in Holland, Netherlands, Germany, and Austria, the three people who were working, asking the similar kinds of questions, doing experiments to answer those questions, and had gotten to some kind of answers to those questions, the same kinds of questions that Mendel had asked, were Hugo de Vries, Karl Correns, and von Schermack. These are the three people who independently discovered some of the laws of Mendel, the 3:1 law, the 1:2:1 law, the two homozygotes, heterozygotes from a crossing of the two heterozygotes, etc. They had independently gotten these. And Karl Correns was later they understood, they got a copy of this experiments in plant hybridization. They read it, and Correns was absolutely dumbfounded. He said, I thought I had found something new, but then I convinced myself that Abbot Gregor Mendel in Brno had not only obtained the same results through extensive experiments with peas, but had also given exactly the same explanation as far as that was possible in 1866. So it's just absolutely stunning and amazing what Gregor Mendel had done. But his laws were rediscovered, like I said, after 1866, for the next 34 years, there were only 3 citations, and it was now his time had come, and people got to know of Mendel's contributions and started, researching on him, trying to replicate the kind of work that he had done, and obtain the same kinds of ratios that he had obtained. He was in some ways quite lucky, in the sense that if you're too far ahead of time, you get ostracized. People ridicule you. People actually didn't ridicule, at least we don't have any documented evidence that people started to ridicule Mendel. He was actually ignored, and that's what happened to him. So he was lucky that he was ignored and not ridiculed. And like I said, that his discovery was way too premature. There are other reasons why his research or outcome of his research did not attract too much of attention. And these are my interpretations. You can take it or leave it. One is that that's a fact that he was not ostracized, so he was lucky that he was only ignored and not ridiculed. He was a monk and did not formally belong to a scientific establishment, and it's he who is proposing these scientific laws. In science, we usually don't entertain people who propose laws to us from the outside of our domain. We are very conservative. We sort of have walls around us. We don't want other people to enter our walls unless they have gone through the same grind. So you have to go through the same grind and make yourself a member of that particular community in order to be able to say something that other people will wake up and listen to you. He was not. He was known as a monk, and that's the reason why scientists did not, again, my interpretation, did not accept what he had to say, and there was this stolid silence when he delivered his speech in the scientific society. Also, if you're too far ahead of time, people don't understand you. So nobody understood him. He applied mathematics to biology. Just imagine, biology is a subject which is completely, usually people take courses in biology if they don't like mathematics. And here is somebody who is using mathematics to understand biology. And therefore, he was way too far ahead, ahead of his time. And it was kind of revolutionary, and so people did not really understand him and therefore did not accept him. Also, if you look at Darwin or contemporaries of that time, whatever happened in nature, people just observed. Some of them recorded, some of them, kept it in their minds and wrote something about it, but it was completely observational. You didn't deliberately do some experiments like Mendel was doing. There were a few people, I said that Mendel had to read some amount of literature, but it was, very, very sparse. And therefore, Mendel did not have many things to fall back on in order to understand how scientific experimentation is done. And he actually devised scientific experimentation. And again, that was way ahead of his time. And therefore, it was considered revolutionary. People did not understand, the value of this kind of experimentation. The last thing that I think is that, he was in a church, and the church would not, to promote his work too much because it was not religious. If he was writing some religious scriptures, maybe they would, but he was not doing so. And he himself was kind of shy. Like I said, that he also had bouts of depression throughout his life, and therefore he did not loudly promote the kind of discoveries that he was making. He only delivered this one talk in that society, annual meeting of the society, and that's about it. So these are the various reasons I think that Mendel was actually not Mendel's work was actually not considered at that point of time seriously by scientists of that time. I mentioned about annexation of Austria by Soviet Russia. 1878 to 1953 was a black period in the world, and that was during the period when Stalin ruled Russia. Well, I'm not getting into the politics of Stalin's rule, but several things happened. Of course, they were trying to promote socialism, and socialism, said that what you learn today, if you are egalitarian, then you pass on egalitarian to your children, egalitarian attitudes to your children. And therefore, if somebody was able to prove that egalitarian attitudes are inherited, that would go well with, socialism. And a scientist by name Lysenko, who became the director of the USSR Institute of Genetics, actually tried to propagate this. He said, if you environmentally change attitudes, change certain characteristics, those will get into the germplasm, and they will be heritable, and they will get into the next generation. So this is what Lysenko, and then again, this is not a talk on Lysenko. Lysenko actually talked about what's called vernalization, and I'll not get into that anyway. So those were environmentally controlled methods of improving agricultural production, and he convinced Lysenko that this is the way to go, which is completely wrong. Today we know it's completely wrong. But Stalin was completely convinced of this. and he banned Mendelian genetics in Russia. This is 1878, before the discovery, but also until 1953. So it happened long after, 50 years post discovery of Mendel's laws. Stalin banned Mendelian genetics in Russia and all countries under the Russian influence. And you know that there were many, many countries, today's countries, which were under the Russian influence at that point of time. What I would like to say to all of you, my appeal to all of you is that this was not evidence-based. What Lysenko was telling Stalin was not evidence-based. It was not done through proper experimentation. And even today, we have from time to time minds waking up and trying to promote non-evidence-based features as scientific facts. And I think we should all rise up and cry hoarse for people who are trying to promote non-evidence-based science. And today also is a time, today's newspaper says that Pythagoras' theorem was discovered during the Vedic times. I don't think that there is enough evidence. I only have read the newspaper that pointed out today, but we need to do a little bit more research on this, but I very much doubt that Pythagoras' theorem would have been enshrined in Vedic mathematics. But anyways, even if it was, it probably is a figment of somebody's imagination more than evidence-based. But our fitting tribute to Mendel will be if we wake up and always raise our voice against facts, against ideologies, against science that's based on ideologies and not based on evidence. Mendel's laws were rediscovered in 1900. The first, so was it generalizable, was a question. And the first generalization of Mendel's laws was done outside of the plants to humans, not to other animals, not to mice, but to humans. And this was done by a British physician. His name is Archibald Garrod, and he was a physician to the Hospital for Sick Children. That hospital is now called Gosh. Very interesting. So if you go to England and say, where is Gosh? People will know what Gosh is. It's a Great Ormond Street hospital, but it used to be called the Hospital for Sick Children. And he discovered this in 1902. And he worked on a particular disease called alkaptonuria, which is a biochemical disorder because of which urine becomes black and parts of the body become black, and they also suffer from other kinds of problems of the kidneys, joints, lungs, and other organs. And what essentially Garrod was able to show is that the inheritance of alkaptonuria from one generation to another actually follows Mendel's laws. And he wrote a paper in Lancet and called this paper The Incidence of Alkaptonuria, a Study in Chemical Individuality. Garrod was also way ahead of his time. He's talking about chemical individuality. Today we talk about precision medicine, right? Just look at this. I mean, how foresightful these people can be. And he, based on his study on alkaptonuria, which is essentially an inborn error of metabolism, and he talked about chemical individuality. So he was also, like Mendel, way ahead of his time. But importantly, Mendel's laws were first proven in the human as opposed to other animals, as opposed to other animals. I also want to pay my tribute to one other, or actually two other people, Francis Galton and Ronald Fisher. It's actually that particular troika, I call them as a troika, that helped us understand heredity. Today is, not today, this year also marks the 200th bicentennial of Sir Francis Galton. He was methods in statistics. He was and we know about Charles Darwin. He was Charles Darwin's half cousin. Charles Darwin was a naturalist, a geologist, a tireless walker, a brave adventurer, and of course we all know what he did. Evolution by natural selection is what he propounded. Origin of Species in 1859. Why am I bringing in Charles Darwin at this point of time? Charles Darwin published The Origin of Species in 1859, and Galton had said that reading that book, Origin of Species, gave him freedom of thought. So he learned to think freely by reading The Origin of Species. And Origin of Species also influenced Mendel a great deal, and that's been recorded. Darwin did some interesting things. For those of you who may have read Origin of Species, it's available in multiple types of printing at multiple prices, etc. Darwin had used fancy pigeons. These are pigeons of, some that are capable of flying for hours, long distances, versus some that do not fly, and so on. So he had used these fancy pigeons to illustrate how natural selection might work. And I'm not going to expand on that at all. Galton asked, can humans be improved by selective breeding? So that was, an iota of his freedom of thought. He started to think freely. Galton thought about these fancy pigeons, and he was thinking that, can humans as a race, and he used the word race, can humans as a race be improved by selective breeding? So as Galton was thinking about that, he said to himself, I have to first show that desirable human characteristics were inherited. Otherwise, how would we propagate that? Otherwise, how can we improve the human race by selective breeding? So he actually started thinking about heredity. He criticized Mendel big time. He criticized Mendel because his laws had ignored, Mendel's laws ignored ancestors, which means that if you look at, the various kinds of traits, the various kinds of characteristics that we have, this is all through our parents. Our grandparents don't matter. Our great-grandparents don't matter. If I know the genotypic constellations of my two parents, that's all matters. Nothing else matters. The previous generations don't matter. This is what we have learned from Mendel's laws. It ignored completely, other than parents, it completely ignored all ancestors, and Galton did not like that at all. He criticized Mendel. So Galton actually set out to identify men of accomplishment, because he was trying to find out, can humans be improved by selective breeding? So he first needed to show that these people with extraordinary characteristics actually could pass on those traits. So he identified men of accomplishment and determined whether any of their male relatives, and he was, I don't know if he was a sexist, but anyway, he was studying male relatives, were also similarly accomplished. He concluded that talent and character were inherited. He published an article called Hereditary Talent and Character in 1865. Remember, 1865, when Mendel actually presented his laws. 1865, Galton had published this in the Macmillan's magazine, which was very popular in the Victorian times. He then went on to collect and analyze family trees of well-known statesmen, judges, poets, painters, musicians, military commanders, etc. So those are the kinds of, wonderful family trees that he actually drew and collected. And he published this book called Law of Ancestral Heredity. Well, no, he published this book titled Hereditary Genius, where he propounded the law of ancestral heredity. And he said hereditary qualities were embedded in the reproductive organs and the germplasm, which were passed on from one generation to the next. Absolutely correct. Except that the kind of characters that he was looking at, he probably were probably dicey. So he proposed at that time, because he was talking about many quantitative characters, he actually proposed many statistical methods such as correlation and regression. He formed what's called the biometrical school, and he proposed, much to the our dismay today, he proposed what's called eugenics, which is selective breeding to improve the human race, which has been completely demolished by later scientific experiments and observations. So he said that he can't believe. Mendel had said that, the inheritance of characters is through particulate entities, particulate inheritance, and Galton completely disbelieved that, because he said that these biometrical characters, such as height, cannot be explained by particulate inheritance. Again, it's not easy actually to think about particulate inheritance and relate that to quantitative characters and continuous random variables, so to say. There were two people who were big supporters of Francis Galton. One was Carl Pearson, and the other is Weldon. So Pearson and Weldon were huge supporters of Galton, and there were two people that we know as Mendel's, great supporters of Mendel, which is Bateson and Punnett. They were the torchbearers of Mendelism at that point of time. They were engaged in a bitter controversy. So the biometrical school and the Mendelian school were engaged in a bitter controversy at that time. Entry of the Genius, Ronald Fisher. Ronald Fisher is the founder of modern statistics. He was born in 1890, died in 1962. And what he did was to publish this paper called, the title of the paper is The Correlation Between Relatives on the Supposition of Mendelian Inheritance. I'll spend 20 seconds on this. Essentially what Galton, Pearson and others were trying to show is the about the inheritance of these biometrical characteristics such as height was to calculate the correlation between parents and offspring and show or between grandparents and grandchildren. And so they had a series of correlations that they were calculating and trying to deduce inheritance from there. And So Ronald Fisher started with these observations and correlations and asked himself, can I explain these correlations using the Mendelian framework? And this paper is very, very difficult to read. It's extremely difficult. There are many reasons why this is a difficult paper, which is that, Fisher didn't have a good eyesight, so he would not write. He would only think in his mind and only write down the final result that he got. So this paper has a book written to explain this paper. So there's a book that's been written to explain this paper. This is amazing. Again, written by two very famous geneticists. So this paper actually showed that you can explain these correlations of quantitative characters using the Mendelian framework. Of course, Pearson would not believe that. Also want to point out there is an underline there, as you can see, it's the Edinburgh. This paper was actually submitted by Ronald Fisher to the proceedings for publication in the Proceedings of the Royal Society, but it was actually published in Royal Society London, but it was actually rejected from there, and it was eventually published in the Royal Society of Edinburgh Proceedings. As I told you, the biometrical school and the Mendelian school were at loggerheads. They were fighting all the time. Pearson and Punnett and these guys were fighting all the time, but they agreed on one thing, that Fisher's paper must be rejected from publication in the Proceedings of the Royal Society London. Carl Pearson said in his review of Fisher's paper, I do not think that the paper is wide enough to be of much interest from the biometric standpoint. Punnett, who was the other reviewer, said, as a contribution to biometry, it may have a real value. I do not feel that this kind of work affects us biologists much at present. So remember, Pearson is the proponent of the biometrical school, torchbearer of the biometrical school. Punnett is the torchbearer of the Mendelian school. And Jim Crow, many of us know him or know of him. Again, my age shows I've met Jim Crow, and Jim Crow has written that this is the only time that the two ever agreed. Oscar Kempthorne, again, a very famous statistician who wrote pages and pages and books on design of experiments. Again, somebody whom I've met, shows my age, wrote in review of volume 1 of the collected papers of R.A. Fisher that it's now regarded as a work of genius, R.A. Fisher's 1918 paper. And then he goes on to say, and this tongue-in-cheek again, Kempthorne, if it is not so regarded, the reflection is on the assessor and not on Fisher. So if you don't believe that this is the work of a genius, if you don't believe that Fisher was a genius, the problem is yours, not Fisher's. And Fisher apparently had said this, we don't know this for sure, but he probably mentioned this to some of his friends, that the paper was sent to a mathematician who knew no biology, and that must be Carl Pearson, and a biologist who knew no mathematics, and that must be Punnett. So this is very interesting. Anyway, a little bit of advertisement from my side. I had given a talk on R.A. Fisher's contribution to genetics, and this has been published. This was in the Fisher Centennial in ISI. This has been published where I've written much more on Fisher and getting this harmonizing the biometrical school and the Mendelian school. Fisher rediscovered or synthesized Mendelism and Mendelian school and the biometrical school. He also did something that we need to know. This may not have been his tribute to Mendel, but essentially, as he was trying to write this 1918 paper, he did a deep study of Mendel, and this is what he came out with. He wrote this paper in Annals of Science called "Has Mendel's Work Been Rediscovered?" And again, I'm not going to get into the gory details of it. This is what he wrote. The data of most, if not all, of the experiments have been falsified so as to agree closely with Mendel's expectations. Comes as a surprise from somebody who actually helped synthesize or put to rest a big war that was raging at that point of time. This is Mendel watching over his garden in the old monastery in Brunn. Mendel died of congestive heart and kidney failure on 6th of January 1884. Just before I leave, I also want to leave you with this thought or with this fact that in this particular paper, Fischer said that Mendel had falsified his data, which essentially means that he probably threw out some portions of the data that did not agree so well with his 1:2:1 ratio or something of that kind. So he actually got rid of these outlier observations that we call today in modern science. One shouldn't have done that. He shouldn't do it, shouldn't have done that. But Fischer did never believe that Mendel himself had done it. He thought that one of the gardeners in the monastery who knew what, after a certain period of time, this was Mendel's work was actually based on about, the estimate is about 30,000 crosses. And obviously, as you are gathering more and more data, these kinds of ratios, etc., were popping up, and Mendel was getting more and more convinced that this is what is happening, etc. And he would certainly describe these to the gardeners who would understand him, etc. So Fischer goes on to say that it is not Mendel who did this falsification. It's probably overzealous, over-enthusiastic gardeners who knew what he was expecting, and they probably put this, put these kinds of things. We would never know. Why would we not know? The abbot who succeeded Mendel eventually became an abbot, who succeeded Mendel after Mendel's death, got rid of all of Mendel's papers. So we don't have Mendel's notebooks anymore. So how would he go and verify? So these all remain as speculations. Mendel's grave has been found, and people are doing, trying to do ancient DNA work. I don't think they will succeed, but they have found a newspaper from 1883 in the grave. And actually, you can't see it. Oh, yeah, you probably can if you're sitting in one of the first benches. That's 1883, and that's a newspaper. So they found a newspaper from 1883 there. That's interesting. Not of consequence at all. But what happened is that they made measurements, etc. They made some estimates from bone density, and the estimate was that his biological age was 65, although his chronological age at the time of death was 62. He measured 167 centimeters, and his shoes measured 27 centimeters of complete irrelevance. So I want to end this talk by wishing Mendel a very happy birthday, and thanking all of you for assembling here and listening to me. Thank you very much.
Thank you, Professor Majumder, for illuminating us with a chapter on history of science, blending Mendel's life and science both. And also, I'm sure we came to know about, apart from biology, like what are his contribution in science and to mankind, and also how that led to flow science and building the or strengthening the chapter of inheritance and heredity. Thank you, Partha, and I also thank all of you who are present here as well as who have joined this program online. So thank you all, and that ends the program here for today.